Imagine a bike that simply refuses to start when you are not wearing the helmet. That's exactly what our project does. Hello everyone, my name is Pragati and I'm here to represent Team Asterix and present our Myosa secure ride system, which we have named the Guardian Link, which is a smart helmet to bike safety interlock system designed to make the helmet usage unavoidable and automatic. Not wearing a helmet is not just negligence, but nowadays it has somehow become a trend, especially among the younger generation. Riding bikes with waving hair in the cool breeze sounds cool, right? But unfortunately, that excitement lasts only for a few seconds. Just one mishappening, and everything just could turn into a lifetime regret. Though the helmets are proven to reduce the risk of fatal head injuries, yet many riders still choose not to wear them. What we thought was why this problem still persists. The issue is not lack of awareness. It is all about the mindset that safety is an option. Current enforcement depends just upon traffic police. All these methods are manual, which is very easy to bypass, especially for short rides. As a result, riders tend to take a chance and neglect the head guard. There was no automatic system that enforces helmet usage because unless safety becomes mandatory by design and not by choice, this problem will always continue. And what we have tried is to give this thought a life. So we introduce to you the Guardian Link, a wireless safety interlock between the helmet and the bike. The helmet and the bike are digitally paired together, and the helmet continuously verifies whether it is being worn or not, and then it sends an authentication signal to the bike, and if the helmet is not worn, the bike will not start at all. This enforces safety automatically in real time and makes the usage of helmet mandatory by the design. Okay, so now I'll take you through the technical architecture of our system, where the decision making is split between the helmet unit and the bike unit. The helmet unit uses Myosa microcontroller board. It reads the sensor data, processes it locally, and generates a secure authentication signal that is transmitted wirelessly to the bike unit without any kind of internet dependencies. And the bike unit uses an external ESP32 microcontroller that receives the authentication data and controls the ignition mechanism of the vehicle. There were some sensors and some electrical components that were used to build these systems. We just have externally used an ESP32 microcontroller to separate the helmet unit and the bike unit. And this separation ensures that the helmet validation cannot just be bypassed at the bike end. And this makes the system even more reliable and secure. Also, to make this system wireless, this separation was important. The system operates in two clear states, which are either the helmet is properly worn or the helmet is not worn. There are a few sensors that are that physically detect and authenticate if the helmet is properly worn or not. And this data is processed into electrical signals and then wirelessly transmitted to the bike unit. And then the bike unit accordingly responds to it. When the helmet is worn properly, authentication is successful and a wireless signal is sent to the bike that ignition has to be enabled. And when the helmet is not worn, authentication fails and no signal is sent to the bike unit in this case. So the ignition remains completely locked. And this is how things work if you're properly wearing the helmet. The authentication process is done by two sensors, which are a proximity sensor and a temperature sensor that confirms human presence inside the helmet by measuring our body temperature, confirms that the helmet is properly physically worn by measuring the proximity between the human head and the sensor that is in the helmet. Authentication is only confirmed when both the sensors satisfy the predefined threshold. Also, I would like to mention that in our prototype, ignition demonstration is done using a buzzer that was provided in the Myosa kit only, which gives an audio indication that the circuit is active and the bike is now ready to start. So we have incorporated some really useful features in our system that focus on post-accident safety, and now I'll take you through it. For fall and crash detection, we have used MPU 6050 sensor, which contains an accelerometer and a gyroscope, and the sensor continuously monitors the acceleration and the angular motion. During a crash or a fall, the sensor values exceed the predefined threshold, and when this happens, the event is treated as an interrupt and it immediately goes into emergency mode. After completely building and testing our system, we realized that riding a bike in real life actually works very differently. Every sudden movement or jerk is not a crash. To handle this situation, our system includes a false trigger management. If a minor threshold is crossed, then the system just flags a possible fall instead of immediately interrupting the whole ride. And the rider can actually manually reset it using the switch and return to the normal mode. This system ensures that only the real crashes are actually detected, while this maintains a smooth ride experience for the user. In the future, we are looking forward to inculcate a lot more features and enhancements is integration of GPS module and GSM module, as I have already mentioned this earlier. This will enable the system to automatically send SMS alerts and live location to emergency services like police and ambulance in cases of accidents and emergencies. To sum up, I would like to say that the Myosa Secure Ride system demonstrates how embedded system and IoT can be together used to enforce safety and not just recommend it.